Hi everyone, I am Shubham Garg and welcome back to the lecture series. Okay, not welcome back, it is actually a new welcome series that is for the tool Cadence. Yes, you heard it right. In this lecture series, we are going to cover the Cadence tool and we are going to see how to make schematic, how to make layouts using Cadence Virtuoso. Okay, so without wasting any time, let us start with Cadence Virtuoso. Okay, so first of all, what we need to do is we need to open our terminal and we need to type this command, that is virtuoso space ampersand. All right, ampersand is basically for opening the virtuoso in background if or any other application are opening. So you will see this kind of log in the virtuoso. All right, so from here, what you need to go to file, click on new and library. All right. So in this file new library, what you need to do is you need to write the name of the library. So let's say the name of the library is new library. All right. So we will name our library that is new underscore lib. All right. And we will click on this. We will be attaching an existing library. So we are going to select this attached to an existing technology library. All right. So when we click on this attached to technology library, what we need to do is we need to search for that library which so first of all we will be clicking apply. Okay, just a second. The moment you click apply, you will see there are these libraries. So to attach to the new library, we will be choosing this GPDK090 as the new library. All right, so we will be clicking OK button and we can see our new library, that is new lib, is created. All right, so this is how we create. First of all, we create a new library. So now let me put some insight on why we are creating a new library and how this flow is actually happening. So you see, first of all, what we are doing in Cadence tool or basically in any EDA tool, what we do is we need to create a library. All right, that is our own library, that is which we created here by the name of new library. Okay, let me just, yeah. So here we created by the name new library. All right, that is new underscore. Okay, my system was hanging. Okay, basically the Cadence is running on this virtual machine, so that's why it is consuming a lot of RAM. All right, I guess now it is fine. Yeah, so we created, first of all we created a new library. Now why we need to create a new library? Because this is the place, this is the physical place where we will be designing all our schematics, where all our designs will be available. Okay, so at this place all our designs will be there, schematic, symbols, anything. All right, that depends on us. Now once we have created library, in a library what we need to do is we need to create a cell. All right, that is, let's say we need to make an AND gate, we need to make an OR gate. So for every any kind of gate or any schematic or any design, we need to create a cell. In that cell of a library, we create a particular design. That is, a library can contain many cells. All right, so basically we create a cell, let's say AND gate, OR gate, NOR gate, anything. So what happens here is that we create many cells, and in a particular library, that is our single library, we can use all these cells, that is these small cells, as the symbols to create the bigger circuit. We can use cells as symbols, we can save them as symbols to create bigger circuits. Now here we also did one thing, that is just now we added a GPDK library. And why we did that? Because you see, we are creating AND OR gate, NOR gate, anything else in this cell view. So now to create that, we need some predefined modules, that is MOSFETs, PMOS, NMOS, inputs, outputs, and all that. So all that thing are already created in existing libraries which are available with this software. So that is why we need to add that library, that particular library, and also for the purpose of adding the technology file, we need to add that library so that we can use the components. All right, so from the components we can create cells inside our own library. All right, so this is how the flow works. So now we can see we have already created a new library. So now let us move towards the next thing. All right, so I am going to click cancel here because we have created finally created the new library. So now what we need to go is we need to go to file, new, and now we can create a new cell view. All right, so the moment we create a cell view, we can see here that this dialog box opens, and here we can name our cell. All right, so now let's say I'm going to name our cell MOS. All right, so now what we need to do is we need to keep all the options as it is. All right, and now we are going to click OK. So we will just wait a second, and you can see here that this kind of window opens up. So that is basically the cell view. Here we will be making our design, and we will be making and simulating the MOSFET, that is let's say an NMOS. So now to create our instance, what we need to do is we need to go to create option, and we need to go to instance. Okay, so you can see when we go to create and we go to instance, this dialog box appears. All right, that is for to add instance. All right, so in library we need to browse the library, and we can select here our GPDK 090 library. All right, in the GPDK 090 library, in the category, what we need to do is we can here select MOSFETs. Okay, and in the MOSFETs we can select any of the MOSFET. So we are going to select this NMOS 1B. All right, so you can see the moment I click on this NMOS 1B, here this is the instance dialog box, that is for the instance of the MOSFET appears. All right, so you can see this appears, and here we can name our instance. That's up to us. So we can see when I am trying to when I am moving my cursor around, you can see there is this small square. So let me just, okay, it is not allowing me to zoom in. I will just hide it, and you can see okay, just a second. So yeah, coming back again to instance, it was just my system was hanging. Actually it is taking a lot of RAM. So from the next lecture I will just reduce the amount of RAM for this virtual machine. Yeah, so in this instance we need to specify this view type as symbol. All right, and here you see the moment we specify it as symbol, we can see the symbol of NMOS, and here we will be specifying the name, that is let's say M1. All right, so now we need to click hide button, and we can add this wherever we want. Okay, so I am just going to left click, and we can see here we have successfully placed the NMOS. All right, so now you can see here the moment I place one NMOS, it is allowing me to place another NMOS, but we don't need that another NMOS right now. So we are going to click escape button. All right, so once we have done this, our NMOS is there. Okay, and here we can zoom in. So we can see this is our NMOS. Now what we need to do is we need to select this NMOS by clicking on it, and what we can do is we can right click, and we can go to edit in place, or we can actually edit any other parameters that we want. All right, so for now I am going to leave it as it is. Okay, and we can see the properties. We can go to edit, we can go to properties, and objects. Okay, we can also press Q as well. It is a keyboard shortcut. So now we can see these are the properties. These are the properties of the object, that is of the NMOS, and here we can make changes on anything, shape, width, point list, any kind of thing we can make the changes. All right, so we were talking about properties. When we click on this MOSFET, we can go to edit and we can go to properties and objects, or we can just press Q. So you can see all the properties are open, and here we can change the name, or we can do any kind of alterations. All right, so now what we need to do is we need to add the supplies to our MOSFET. All right, so now I will tell you how to add the supplies, and we will be adding the ground and VDC from the other libraries. All right, so first of all we are going to click OK here, and next we are going to add the ground and VDD. So what we need to do, the same way we added the instance of this NMOS, what we need to do is we need to add the instances of voltage sources and ground. Okay, so just click on browse, and you can see here, that there is this analog library. So from the analog library, what you need to do is you need to go to analog library, and you need to search for VDC and ground. So you need to search for this VDC, just select here, okay, view type symbol, and let's name it VDC, and we are going to add it here. All right, we will click on escape, and similarly we are going to create another instance, and that is for the ground. So here we are going to search for ground, and in this we are going to add this instance. We are going to change the name first, that is ground for GND. Okay, so this is how we are going to add the instances, and here I am going to just add ground here. Okay, and I am going to press escape. So this is how we added VDD and VDC and ground. Now what we need to do is we need to create wire. All right, so there are two ways to create wire, that is go to create and wire, that is, or we can press directly press W. All right, that is, I can hover here and I can press W, and I can now just mouse click and connect all these wires. All right, so here we have VDC. Okay, now what we need to do is we need another VDC and we need another ground. All right, so here, okay, first of all I need to click escape for the wire. Yeah, so I will click it here. I am going to copy and I am going to paste it here. Okay, that is for the VDC for the input. So similarly I am going to click the copy again, and I am going to paste one here. Another I am going to click copy, and I am going to click it here, and I am going to paste it here again. All right, so now I am going to press W. So by pressing W I am going to connect these two, that is, this is for the input. Yeah, all right, and now one more thing, we need to connect this, that is the substrate, and we will be connecting it here. All right, because this is our source. So this is how we made the connections of the NMOS. So this we have completed the connections of the NMOS. Now what we need to do is we need to click on the option, we click on the save option. Okay, so you can see here there is check and save option, so we need to click on this check and save, and if there are any errors then this option should tell us. And so it seems that there are no errors, so our design is saved successfully. You see there are no errors. Okay, and now what we need to do is we need to perform the simulation. All right, So basically for this simulation, that is schematic simulation, the tool for Cadence is Spectre. Okay, that is the spice circuit simulator. All right, so we will be using this simulator, that is with the Cadence Virtuoso, to perform the simulation. So for that we need to go to launch. Okay, and we will see ADEL to that is the analog design environment. Okay, so L for launch. So we will be launching the analog design environment. All right, so here you can see there are various kind of options. So first of all, we will be choosing the type of analysis. So we will be selecting analysis, and we are going to click on choose, and you can see there are a lot of analysis that are available, and we are going to pick DC analysis. All right, and we are going to check this save DC operating point. All right, and we are also going to check this hysteresis sweep. All right, so these are the options we are going to select. And here what we are going to do is we are going to let's just click on options. All right, not right now, or let's say just leave the hysteresis sweep at this moment. So we will just leave it as it. Okay, so we will be leaving it as it is, and what we need to do is now we need to click on, let's see the options first. Once again, yeah, there should be some start and stop options. I guess it will ask us later, so I'm going to click OK. All right, so we can see here that there is this analysis, that is this analysis which needs to be done. So now what we need to do is we need to click on outputs, and we need to set the outputs to be plotted. All right, so we are going to click to be plotted, and we are going to go select on schematics. Okay, so from now we can select the nodes for the output, that is from where we are going to see the output of the schematic. So for that we need to select this drain of the NMOS. Okay, this is the drain, so this is the output, and now we can see here, in this output there is this option, that is drain. Okay, so once we have selected this, what we need to do is we need to hit the play button. So here you can see there is this play button, green button. So we are going to hit this button, and we will wait for the simulation to run. So it is processing, and the simulation is about to run. So we can see simulation is running. There are some information in this. So we will just wait for the graph to be plotted. So the graph should show the output of this NMOS. Okay, that is the output current with respect to the voltage. That should be our graph. All right, because we have selected drain as the output. So let us just wait for the simulation to run. Okay, it is still running. Okay, before running that, one more thing we forgot, that in this when we are setting the analysis type, we need to select this component parameter option, and here we need to add the name of the component. All right, and we need to add the start and the stop time. Okay, so and the parameter name. So we are going to select this component. Okay, so again it got stuck, my system got stuck. So anyways, so we are going to select the component, okay, and that is this VDC. So we can select the output voltage or the input voltage. It's basically up to us. All right, whatever needs to be plotted. So here we can it's up to us which component we need to select. All right, so we are going to select here I have selected the output voltage, and I am going to plot the output voltage with the output current. All right, so here what we need to do is we need to click on the start time, that is start time is 0, and we will, let's say, stop time we give 1.8 second, and we will be giving the sweep type linear, and step size will be 0.01. all right, so now we are going to click on OK, and from now we can see here these are the options which are available, and now we are going to run this. Okay, that is, now we are going to plot the graph. So it is running now. Okay, so yeah, sorry for that, my system was hanging once more. So let's look at all the options once again. Okay, first of all, let me tell you this is the VDC voltage. I have named it VDS, that is drain source voltage, and this is the one for the input, that is VGS. all right, and this is the drain terminal. all right, so now we are plotting VDS versus ID. all right, so for that, first of all, we need to go to analysis, and here you can see this is the analysis. So I will just close this, delete this. I will delete this either, and I'm going to go to analysis, and I'm going to go to choose. Here I'm going to select DC analysis. So here I'm going to take save DC operating point and component parameter. In the component name, we need to select the component. So we can either select this source, that is for the voltage, and if we need the component to be the current, we need to select these nodes. So here we will be selecting this voltage source. So in this you can see here this component name already here because I clicked on this, and parameter name I am going to write VDC. Okay, so the start will be from 0 and the stop will be 1.8. all right, and here I'm going to add the linear. So this step, let's say it is 0.01, and I'm going to click OK. So now we can see here that already after clicking OK, this is the analysis. Now we need to set the output that is to be plotted, and we will be selecting on the schematic. So here we are going to click on this node because we need the current. So here I am going to click on this drain so that it can plot the ID. So you can see here that this is the drain output for the drain. So now I am going to click this netlist and run button. So the moment I click it, it will start running. Okay, right, it is saying there is some error, that is in the operating point. Let's see. Okay, the parameter name is not VDC, it is the DC because we are doing the DC analysis. Sorry for that. So just click OK, and again click on netlist and run. And you can see the moment it runs, it is showing the plot for ID versus VDS. Alright, so this is how we can simulate an NMOS using Cadence Virtuoso. Okay, here you can see how to create a schematic from Cadence, that is from importing the symbols from libraries and components from the libraries, creating a new cell, and finally simulating the NMOS. Okay, and we have used Spectre, that is for the simulation for Cadence Virtuoso to simulate our NMOS. Okay, so I hope it is clear, and this is all for this video. See you guys in the next video.